Okay, ladies and gentlemen, today we are talking about congruent polygons for Unit 1, Lesson 3. So, how do we know if they're congruent? Well, there are different classifications. For example, when we have side, 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 guess what? That means all the sides they're congruent. So, for example, triangle AB is congruent to triangle DE, or side AB is congruent to triangle side DE, sorry. And you can tell this because there's one hashtag or hash mark. Here we have two hash marks, which means side BC is congruent to side EF because it has two, and so on and so forth. Otherwise, the way that they are congruent would be side angle side. So side angle side, they have a side that's the same, they have an angle that's the same, and then they have another side. Same thing. So for example, angle L is congruent to angle Q. And this little weird little squiggly thing, the one that goes squiggly and then two lines, means congruent. Okay? And you can also have an angle, then a side, then another angle. That's another option. So you can have side, 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 or angle, side, angle. Okay? Now, let's talk about how we prove this. So first of all, we know that we're given information that tells me angle A is congruent to angle D. Okay? You can tell this because it has the little hash marks and has the little things. That's a given. We also know side AB is congruent to side ED. And you know this because of the two little marks. Okay? Now, we know that side BC is congruent to side EC, or CE, and that's a given. Now, we know this because triangle ABC is congruent to triangle CDE because of a side-side angle postulate, because it's side-side angle. Okay? So that is how you write this two-column proof. So when you are working on your things, I am expecting that you are doing these two-column proofs. They aren't nearly as difficult as you think. We're just doing the basic ones. So for example, we are told, so let's look at this. Actually, let's change the color. I want something else. So we are told that side K, or angle K, is congruent to angle U. So I have that. And then I could say side LK, or KL, is congruent to side ST. See how it only has one little hash mark? Again, we have that, that's a given. Now, our last one, angle M is congruent to angle S. Again, that's a given, awesome. Now, how do we know what it is? It's an angle, angle, side postulate, or a side angle, angle, depending on how you want to say it. But really and truly, these are our main ones. So the ones that you really want to focus on, side, 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 side angle, side, angle, side, angle. Okay? So we're going to try and fit them into those. Good. Now, these are similar polygons, but they're not congruent, which is completely different. Remember, when they're similar, that means that they have a relationship to each other. If this was congruent, that would mean that 5 centimeters, this would have to be 5 centimeters, but they are similar, okay? So it's that whole proportional things. So triangle ABC is similar to triangle DEF. They have proportional sides and congruent angles. So the angles will usually be congruent, so you won't have to worry about that. But when, for example, 3 to 6, we know that that's multiplying by 2, and we can either be getting larger or smaller. In this case, they said we are getting smaller. Okay? And so they have proportional sides, but they have congruent angles. Because I can make a triangle that's as big as a house, the angle is not going to change. Okay? Now, let's talk about different types of transformations. There is a translation, okay, where you just move it. All it's doing is shifting. It does not turn, it doesn't flip, it doesn't do anything. It's just, I took it from here, I moved it to here. Okay? You have a reflection. Go look in the mirror. So whichever axis, so in this case, this would be the y-axis, and it's being reflected on both sides of the y-axis. okay? Or you can have a rotation. Now remember, rotation is when we turn, and we have one point usually that we're rotating around. In this case, we're rotating around this point this point right here, and it's being rotated by a certain number of degrees and is being rotated clockwise, or possibly counterclockwise, depending on which way we're going, okay? Now, translations, I'm picking this up and I'm moving it. Reflection or flip is when you're looking in the mirror and it's a mirror image. Now remember, with mirror images, they're backwards. And then the rotation is when we're turning things. Okay, so let's look at this. First of all, the first thing I need to do is make sure that we label this. So I want A, B, C, and then we'll do D, E, F. Okay, so the first thing I'm going to say, just to make my life easier, so I'm going to say side CA is congruent to side FD. How do I know this? It's given. So this column is kind of like, how do you know this? So angle A is congruent to angle D. How do we know this? Well, it's given. And side AB, and that's when I draw the line on top, that means that's a side or length, is congruent to length or side DE. And sometimes we might have to write this out. That's a given. So that means triangle ABC is congruent to triangle DEF. Now how is it congruent? Oh yeah. So we've given a side, an angle, and a side, which means it's just going to be side, angle, side. And we're done. Okay? Now look at this one. This one's a little bit more complicated. We've got a whole bunch of stuff going on. Move J down 3 places. Okay? Oops. Wrong thing. Come back here. Move J down 3 places. I was trying to make this bigger. So I'm going to move this 1, 2, 3. Oh, 3 places and to the left. So 1, 2. So this is my new J, and I'm calling it J prime. Move K down 3 places and to the left 2. So 1, 2, 3, 1, 2. Here's my new K, and I put a little comma after that to show that's my second one. And then L is 3 places and left 2. 1, 2, 3, 1, 2. So this is L prime. So first of all, what kind of transformation is this? Good! It is a translation because we just shifted it. It's the exact same thing. I just took it and said, I'm moving you. Now the new position of J prime is going to be -1, +3, because remember we have to list our x coordinate first and then our y. So our x is -1 and our y coordinate is 3. Okay? And that's it. If you guys have questions, let me know. Otherwise, I will talk to you later. Bye!